Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim Haikal bin Muhammad Sazali. Today I would like to present about my final year project, which is study of vehicle dynamic on motorcycle in terms of ride dynamic by using Arduino. So we go for the abstract first. For the abstract, tire are an important component of a vehicle that affect the motorcycle ride and handling performance. The fundamental function of a motorcycle tire is to provide a comfortable ride by reducing body vibration and increasing driving performance by maintaining constant road wheel contact. An investigation into how motorcycle sprung and unsprung mass affect motorcycle ride and handling performance. Tire is a major influence in motorcycle ride and handling performance. Two MPU 6050 will be installed at the Yamaha 135LC motorcycle to measure the vertical motion of sprung and unsprung mass in the experiment. A gyro sensor, which is an MPU 6050, also collects the data on the vertical body acceleration, pitch and roll. This study will include the road experiment, two road experiments which are straight and curvature road. The experiment will be done with the 30 to 40 km per hour on straight and curvature road with varying tire pressure is set in the range of 24 psi to 38 psi. Arduino IDE software is used to collect data from the sensor MPU 6050 that will provide data in acceleration, gyro and angle. This study success will improve the research and consumers' riding and handling abilities. So untuk terang dengan lebih lanjut, saya punya eksperimen ini berkaitan dengan yang pemboleh ubah dia tire pressure. So tire pressure yang akan digunakan adalah normal, low dengan high. So dekat sini sensor akan diletakkan di sprung, iaitu di bawah seat motosikal, dan unsprung dekat swing arm motosikal. So kedua-dua sensor ini akan membaca data dalam bentuk pitch dan roll. Untuk pitch untuk straight road dan roll adalah untuk kita punya curvature road. So kita pergi kepada introduction. So for introduction, dynamic of vehicle is the word used to describe the direction and dynamic of road vehicle rely most on classic mechanical engineering. All significant components of the dynamical vehicle system include the body, which is sprung mass, suspension component, spring and damper, and the tire component, which is unsprung mass. Dynamic performance may be divided into three areas according to the direction of force, which are lateral dynamics. They include handling, longitudinal dynamics that involve acceleration, and vertical dynamic that have ride and passenger performance. So after that, we go to the literature review. For the first literature review, which is the effect of the inflation pressure on the tire properties and the motorcycle stability. So finding for this research is the change of inflation pressure on tire will affect the stability of the motorcycle toward the riders. So for the second one is significant of tire pressure monitoring system in motorcycle. So finding for this research is a tire with low tire pressure is called underinflation, which will increase the tire contact patch to the road. So the tire with high pressure is called by overinflation, that will decrease the tire contact patch to the road, and it will lead to the accidents. So for the third one is working principle of Arduino and using it as a tool for study and research. So Arduino is a free and open source microcontroller that can be programmed, erased and reprogrammed at any time. So for the fourth one is semi-active suspension on motorcycle. And finding for this study is this design is connecting the semi-active with the electronic control unit ECU to ensure the vehicle dynamic and to get the best performance and also comfort in riding motorcycle. And the last one is self-stabilizing by using gyroscope. Finding for this paper is gyroscope sensor are used to stabilize the bike, so the bike can balance itself without any support. This can make the rider more comfortable while riding it. Okay. So we go for the methodology for this these studies. So for the first one, we have to come up with the problem statement with this topic. So we have to, after that, we have to find the literature review or the previous study of research about our topic. So after that, we have to identify the objective and the scope, and also define the experiment parameter. So after that, we go to the setup. We go to the next, which is set up the experiment to install sensor to the unsprung and unsprung part of the motorcycle. As shown in the figure, for the unsprung will be installed at the swing arm of the motorcycle, and for sprung under the seat of motorcycle. So this experiment will be run with the Yamaha 135LC motorcycle. So this motorcycle will run with the speed 30 to 40 km per hour in the straight and curvature road as shown in the figure. So motorcycle tire pressure is set in the range of 24 to 38 psi, as shown at the table that I have made. So for the normal tire pressure, for front tire we will use 29 psi, and for the rear tire 33 psi. For the low tire pressure, for front is 24 psi and for rear is 28 psi. So for the height tire pressure, for front is 34 psi and for the rear is 38 psi. So after that, after we be running the two road experiment, we will compare the three motorcycle tire pressure result. So analyze then discuss the data that have been collected, discuss and make the conclusion and recommendation for this study. So that's all. We go to the next, which is result and discussion. For this straight road, we will make 3 experiments with the 3 tire pressure, which is normal, low and high tire pressure. So for the first one is pitch motion for normal tire pressure. This experiment takes 7.5 seconds to be done. Height peak sprung at 0.81 G and negative 0.57 G for unsprung, which is at this state. So we go to the next one, which is pitch motion for low pressure. This experiment takes 5.6 seconds to be done. Height peak for sprung and 0.04 G for unsprung, which is at this state. So after that, we go to the height pressure. The experiment takes 6.6 seconds to be done. Height peak sprung at 0.8 G, which is at this, and 0.45 G for unsprung, at this. So kenapa dia ada high peak dalam saya punya eksperimen untuk straight road ni? Ia disebabkan oleh jalan yang saya lalui itu tidak rata, disebabkan ada kesan tampal jalan. So dia tidak samalah dengan keadaan jalan yang asal. So akan menyebabkan ada sedikit kenaikan macam kita melalui bonggol. So akan membaca lah, memberi bacaan vibration yang high peak untuk tiga-tiga eksperimen. So dekat sini saya ada sertakan table untuk lebih memudahkan untuk kita lihat nilai-nilai untuk tiga-tiga tire pressure tersebut. So kita pergi kepada seterusnya, iaitu result untuk curvature road pula. So untuk sprung dan unsprung normal pressure. So the normal pressure experiment take approximately 4.7 seconds to be done. The graph for ZEO for sprung show an increase 32.7 seconds to 35.4 seconds with the highest point of 31 degrees, which is at this point. And for X roll at 35.1 to 36.1 second, the height P is 29 degree, which is at this state, which the motorcycle will make the maximum leaning with the 61 degrees. So for the unsprung, for this graph, it shows the increasing value of Z yaw for 32.6 second to 35.1 second, and the maximum value is 26 degree per second. So for the X roll at second 35.1 and 36.1, the maximum value for roll motion is negative 12 degrees, which is at this state. So we go to the low tire pressure. So for the low tire pressure experiment, take approximately 4.6 seconds to be done. The graph for Z yaw for sprung show an increase of 28.6 seconds to 31.1 seconds with the highest point of 28 degree, which is at this point. So for the X roll at 30.6 to 31.3 second at the high peak is 26 degree, which the motorcycle made the maximum leaning with the 64 degree when turning to the left. For unsprung, it showed the increasing value of Z yaw from 28.6 second to 31 second, and the maximum value is 29 degrees. For the X roll at the second 36.6 to 31.3 second, the maximum value for roll motion is negative 13 degrees, which is at this state. So we go to the heart pressure. So for the heart pressure experiment, it take 4.7 seconds to be done. The graph for Z yaw for sprung show an increase of 28.8 seconds to 31.1 seconds, with the highest point of 29 degrees per second. For X roll at 30.3 and 31.4 second, the height peak is 25 degree per second, which the motorcycle made the maximum leaning with the 65 degree, which is at this and at this state. So for the unsprung, it showed the increasing value of Z yaw from 28.8 second to 31.1 second, and the maximum value is 26 degree per second, which is at this point. So for X roll and X roll at seconds 30.3 and 31.4 second, the maximum value for X roll motion is negative 14 degree per second, which is at this state. So untuk lebih nampak, saya akan buat table yang berkaitan dengan tiga-tiga eksperimen di jalan curvature. So untuk normal, untuk roll punya bacaan adalah 29 dan yaw 31. Untuk low roll 26, yaw 28. Untuk high pressure roll 25 dan yaw 29 untuk dia punya maximum angle dia. So untuk pengiraan untuk kita kira maximum leaning rider tu bila dia corner ke kiri, bila saya corner ke kiri, so kita akan ambil nilai roll which is 29. So 90 tolak 29 kita akan dapat 61. So 61 degree lah bila kita corner ke kiri. So untuk yang low pula 90 tolak 26 kita akan dapat 64. So 90 tolak 25 kita akan dapat 65 degree. So untuk ketiga-tiga tire pressure ni, apa yang kita boleh buat kesimpulan ialah kesimpulan untuk ketiga-tiga ni sudah tentu normal tire pressure memberikan yang lebih baik lah, cengkaman tayar yang lebih baik kepada jalan. So normal ni lebih selesa lah untuk rider corner ke kiri atau kanan dan dapat mengelakkan kemalangan daripada kemalangan berlaku lah, daripada slipping ke tergelincir ke daripada jalan. So itu saja. So kita pergi kepada kita punya untuk study ni, the goal is to study vehicle dynamic on motorcycle using an Arduino, which include motorcycle body motion and change in motorcycle tire pressure was made. The experiment that show the increased tire pressure will provide lower right performance and handling during the curvature and straight road. Other than that, normal tire pressure that have been set from Yamaha manufacturer give the perfect ride and handling performance when riding. The rider should follow the tire pressure that have been set up by the motorcycle manufacturer to get the best ride and handling performance during the ride. So my reference for this study, which is in this poster. So that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.